Hello and welcome to this week's edition of Labrats. So in the kit that I gave you this week, you will have received a red solo cup and some soil, and that is to plant your pea. So it's been about 4 weeks since you would have planted your little pea seed, and mine has started growing leaves and has a pretty intricate root system. And so I figured it was probably time that we actually planted them. So I'm also going to plant mine, and then we can follow along with the developmental cycle of how a plant will grow into an adult plant and start producing pea seeds of their own. So if you want to do that this week, that will be great. And this week we're going to take a little bit of a detour from all the biology that we've been focused on and start getting into physics. So last week you did a yeast experiment, and that was just basically to highlight that sometimes things that don't seem alive are in fact alive, and that they're actually very important in our ecosystem. So we added some yeast to water, which wakes them up because they're in a dormant or a sleeping stage, and then you add sugar, and that's something that they can feed off of, and then they digest that sugar and produce gas as a result. So that's what we did last week. And this week we're going to be looking at basically states of matter. So physics is all about the world around you, how things move or how they don't move, gravity, so like why we don't fall off the face of the planet even though we're on a round spinning object, how light works, how sound travels. So we're going to start out with something a little bit more simple, and we're going to start out with the states of matter. So matter, which is what makes up the entire world around us, we're made of matter, the table's made of matter, the house is made of matter, everything in our universe is made of matter, which are basically tiny little particles that lock together. And there are 3 major states of matter. So there are solids, liquids, and gases. And some substances can actually transfer from being one state to another. So water is a really good example. When you freeze water and it becomes a solid, it becomes ice. When you melt ice, it becomes a liquid. And when you boil water, it becomes a gas, just like the oxygen or the carbon dioxide in the air we breathe. So this week we're going to look at something that is a little bit confusing because it appears to be in an in-between state. And you will find in life as you move along that basically everything has a lot of gray and in-between areas like that. So I figured it was a good experiment to start with. So in your kit you will have some cornstarch, and cornstarch is really what it sounds like. It is starch from corn. So starch is a molecule that's produced by plants that later can feed off of. So the reason why potatoes kind of have that kind of granular taste to them, the reason why corn has sort of a similar thing is because they produce or they store a lot of starch in them for the plant to feed off of. So this is basically corn food produced by plants, which now we have an idea about because we've already studied a bunch of plants. So what you're going to do is you're going to pour your cornstarch into a bowl. So you can do that, pour your cornstarch into a bowl. And then I actually, you should feel what exactly this feels like. It actually has kind of an unpleasant feel. I don't really like it. It's like it kind of squeaks when you touch it, and it almost feels like it's interlocking or something, which is really important for actually how this experiment works. Then you're going to take your water, a half a cup of water, and you can add some food coloring to it. So I did provide you with food coloring. It's red this time as I get it all over my hands. You don't want too much because if you put too much in, it will get all over the place and will dye your hands. So if you have other colors at home, feel free to use them. So you can add your food coloring to the water, and then you slowly add the water to the cornstarch. So when you first start doing this, it's going to have like almost like it's becoming like a crunchy solid. It's a really funny kind of feel to it. You can see that it's becoming a solid as I get it everywhere. Your parents are going to be really impressed with this one because cornstarch is so much fun to deal with. So you really have to spend a lot of time stirring it because it's really hard to stir, especially at the start, because it's so it doesn't really feel sticky. I don't even really know. I'm struggling with how to describe how it feels. Crunchy is the best I can come up with. But you want to be really careful about how much water you do add, because it's really easy to go from, this doesn't seem like enough water, to having too much water, and then you'll need more cornstarch. And I only gave you 1 cup of cornstarch, so you got to be really careful, but I'm sure your parents will have some kicking around because you do use it in cooking too. So you'll see that it's kind of becoming like a liquid, right? Like you move it and it jiggles just like a liquid should. So this fellow named Sir Isaac Newton, who lived in the 1600s, so like 300 to 400 years ago, he kind of came up with the idea behind modern physics, so the modern understanding of how the world around us works. And he defined what a liquid is. So it might seem silly that we have definitions for liquids and stuff, but we do. And basically the unifying idea behind liquids is that they all flow at a uniform rate. So if you think about water, you can pour it out and it's always going to flow more or less the same way, right? So that's what a liquid is. And when you look at this, it kind of behaves like a liquid, right? Like it seems like a liquid. I have another one prepared here, and I made this one blue. So when you look at this, it really does seem like a liquid, right? Like it flows. But when you hit it, it actually behaves like a solid. And so this is what we call a non-Newtonian liquid. So a non-Newtonian liquid is between being a solid and a liquid. So it might flow like a liquid, as we can see here in the bowl, but when you hit it or slap it, it actually behaves like a solid. So the reason it does this is because the cornstarch, when it's not under a lot of pressure, or when you're not putting a lot of pressure on it, right? Like we're just slowly easing this spoon into it, and so it behaves like a liquid, or we're just sloshing around in this bowl. Basically all the little matter molecules in it, they relax, and so they can flow easily and slide past each other. Whereas when you hit it really hard, like this, those little particles lock up, kind of like a puzzle, and they don't slide past each other. And something that is in a lot of cartoons that we talk about is quicksand. So this is actually how quicksand works. So quicksand is just a mixture of water and silt particles, and silt particles are like, they're smaller than sand particles. They're almost like dust, and you get like so much silt in liquid, and they're suspended in the liquid that they basically float, which is exactly what the cornstarch is doing. The cornstarch is suspended in the water. It's not dissolved in the water, it's suspended. And so when you sink into quicksand, it basically acts the same, and it like sucks you in, because when you're just sitting on the surface of it, it acts like a liquid, but when you start to struggle and move in it, it locks up and behaves like a solid. So that is an example of a non-Newtonian liquid. So this is actually like an in-between state of matter that is called a suspension. So a suspension is when you have particles that are suspended or just kind of floating, hanging out in water, and it can flow like a liquid, but when a lot of force is applied to it, it actually behaves like a solid. So you can play around with this because it's really cool. Since I've made this, the people who live with me have spent a lot of time playing with it. So yeah, I think it's a lot of fun. So if you have any questions about this, you can ask them in the comment section of this video, and I'll see you next week.